Hi students, how are you? I think it's fine. And we already discussed about the ecosystem, we already discussed about the resources, and we already discussed about the few previous topic of the general part of the environment. But today we'll discuss about the another topic which is also very much important. And this topic is included in the general part of the environmental science. The code for the environmental science for all semester, either MC 301 or for even semester MC 401. Myself, Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering, welcome you in my class of population growth. So today we'll discuss about what is the population growth, okay, or what is the mathematical equation of the population growth. Then we'll derive that how we can establish the equation of exponential growth model, okay. So how it is possible to develop the exponential growth rate equation, okay. So next we'll discuss about, from the exponential growth rate, we'll discuss about the doubling time of population. This is generally represented by TD. Then we'll discuss about the half-life time of population, and this is also represented by T-half. Then we'll develop the relation between we'll develop the relation between TD and the T-half. Then what will be the graph of the population according to the exponential growth model, okay. So what equation will established according to the equation of what will be the nature of the graph, this we will also discuss in the today's class. Then we'll discuss about there is some drawbacks or the result which will get from the exponential growth model. This result, why not suitable, why not, or what are the limitations of exponential growth curve. These things also we'll discuss in our today's class. So let's start the class. So first of all, what is the population, or what is the population growth? How we can define the population growth? Population growth can be defined as the change of strength of population per unit area at a particular time. That means the rate of change of population, the strength of population with time for a particular region or for a particular area is called actually population growth. Now, first of all, there are some few questions arise that why we have to read or we have to study the population growth. Okay, so that means the population growth study, what is the requirement or what is the beneficial side of the population growth study? When we are doing something, that means suppose for a particular area, if we want to construct something, then we have to predict that what will be the future population for that particular region. That means if we want to develop some kinds of water plant, okay, water supply system, then we have to understand that after 5 years or after 3 years or after 4 years, what will be the population for that particular region. Or there is some problem regarding the resources, okay. What is the resource? I already discussed in my previous class. Now think about that there is a direct relation between the population growth and the resources. That means the resources, different kinds of resources are decreasing with time. And if you think about the fossil fuel, so fossil fuel will be finished after some years. So that all the things are very much related with the population growth. That means if the rate of population growth is very high for a particular region, then what happen? The resource will be decreased with very high rate, isn't it? So that means we have to study for different kind of necessity. We have to study the population growth or population growth study. We have to continue to understand properly for different type of things or different type of purpose. Okay. So now generally if we consider a particular region, then there are three factors actually which control the population growth. First of all, the first factor is that all of you know very well, that is the birth rate. Okay, so the first factor which control the population growth, that is the birth rate. Okay, the second factor is that obviously it will be the death rate. Okay, so if the first factor will be birth rate, second factor will be obviously the death rate, and the third factor will be the migration rate. Okay, you know, for a particular region there are some kinds of migration rates are also there. So the third factor is that migration rate. Okay, so these three factors are very much responsible. These three factors are very much responsible for the population growth study for a particular region. First one is the birth rate, second one is the death rate, and the third one is the migration rate. Okay, so overall population growth study, that means of what we are trying to do today. There is some calculation also, mathematical calculation also, by which we can determine the population growth. Actually that population growth study depends on that three factors. These three factors actually control the overall population growth of any particular region. Okay, so now there are actually two types of population growth study there. Okay, so first one is the two types of population growth study, means actually by the two method we can calculate, or we can do the population growth study. So first one is the exponential growth model. Okay, so first one is the exponential growth model. Okay, so it is the first one, exponential growth model. So this is the first model, and this is the most simple model by which we can do the population growth study. And second one, that is very logical, and that is very appropriate, and this model is called logistic growth model. Okay, so this model is called logistic growth model. So these two model we have to study, or we have to read. Okay, so logistic growth model. Okay, so first of all we will discuss about the exponential growth model. And you know that in this model, exponential growth model, there are some drawbacks. That means we'll get some kind of error. That's why we have to go to the logistic growth model. But if you do not understand exponential growth model properly, it will not be possible to understand logistic growth model. So that's why we have to understand clearly what is the exponential growth model at first, then we will move to the logistic growth model. So according to exponential growth model, that according to this model, that the population that is directly proportional to the size of the population at that time. So that means that if the population of any place, if the population in any place is nt at any time t, so suppose there is a population nt for a particular place at any time t, then according to the exponential growth model, dnt by dt that express the population growth rate, dnt by dt that express, dnt by dt means a rate of change of population with time. So dnt by dt that proportional to the nt, dnt by dt that proportional to the nt, because according to exponential growth model, the population growth rate, that dnt by dt, that very much proportional to, according to exponential growth model, population growth rate, this very much proportional to the population of that area at that time. So population of that area is nt, at that time t. So according to that exponential growth model, we can write down in the mathematical formula dnt by dt proportional to nt. dnt by dt population growth rate of change of population with time, and nt is the population of that place at that time. So to remove the proportionality of what we have to do, we have to take one constant. All of you know very much that to remove the proportionality we are taking one constant, and the constant is called r. Okay, so what is the r? R is the exponential, you have to keep in mind, r is the exponential growth rate constant. Exponential growth rate constant. Okay, so this is one type of constant. Okay, you know, to remove the proportionality we have to take one constant, and here we are taking the r. So r is the exponential growth rate constant. So finally we are getting dnt by dt equals to rnt. So now here, look here in the next line that that here if we integrate it, then what will be the integration? That integration will be here, look here, that integration of dnt by dt. So from that line, from this line to this line, so integration of dnt by dt, that equals to integration of rnt. Okay, and you know very well that integration of dnt dt that produce ln nt. Okay, so this produce ln nt, and ln nt equals to the integration of this part, this will produce rt plus z. Okay, so z or c, whatever, this is called the integration constant. This is called the integration constant. Okay, so here we have to find out that what is the value of z. Okay, we have to find out that what will be the value of z. So how we can find out the value of z? So you know, when we trying to find out the value of something, then we have to take some terms as the zero. So here the most simple way, that in the beginning time. Okay, now this word may be confusing. Some students think that beginning time means when the earth was formed, or the starting time of the earth. It is not actually. Beginning time means when we started to count the population for a particular place at that time. This is called the beginning time. Okay, so for example, if we started to count the population at 2010 in a particular area, so this was the beginning time. Okay, so this time what was the population, we are taking it as the n0. Okay, actually it is the n0. Okay, so now if it is the n0, it is the beginning time, that means when we started to count the population, obviously this time it n equal to 0, we can consider this time t equal to 0. Okay, n and nt, that equals to n0. So when we started to count the population, t equal to 0, obviously t will be 0, and nt we can write down n0 because at that time population was n0. Okay, so now look here, from that equation we can write down, that ln n0, okay, in place of nt, now we can in place of nt now we can write down it will be the n0. Okay, so just in place of nt we are writing here n0. So ln n0, that equals to r, in place of r. Okay, but t equal to 0, because at that time time was 0. Time was 0 means it is the starting time, there is no, so that's why it will be 0. So t equal to 0, and t equal to 0, and then we can write down z equal to, what will be the z? So z equal to ln n0. Okay, so if it is ln n0, that means the equation reduces to, if that equation we can write down, then equation reduces to only ln n0 equals to z. because RT will be 0. If RT 0, then remaining part will be Z equals to ln n0. So finally what we got, Z equal to ln n0. Now our duty is to put the value of Z in the previous equation. That means we have to put the value of Z in the previous equation. So if we put the value in the previous equation, then what happen or what we'll get? So we will get then here, if we put the value of Z equal to n0, then the equation reduces to ln n2, not reduces to, actually equation modified to ln nt equals to RT plus ln n0. Okay, so ln nt equals to RT plus ln n0, and from that equation we ln nt, if that ln n0 will come to here, then ln nt minus ln n0, that equals to RT, and finally what we'll get, ln nt by n0 equals to RT. That form you have to keep in mind, or from that form we can also write down ln only nt equals to n0 into e to the power RT. So one thing you have to keep in mind, that after integration we will get the EVS. Okay, so that's why look here, nt equals to n0 into e to the power RT, or we are writing here ln. Okay, so nt equals to n0 into e to the power RT. That equation is very important to solve the numerical problem. I will also give you one numerical problem for you. There you have to use this equation. Okay, now from this equation we have to find out that when the population will be double with respect to the initial population. Okay, so when population will be double with respect to initial population, that this is actually represented by T in suffix D. Okay, so T means time, D means doubling. Okay, doubling means when population will be double with respect to initial population. So that's very simple. With respect to initial population will be double means easily we can take it that nt equals to 2n0, isn't it? So if nt equals to 2n0, just we replace that in the place of the equation was nt equals to n0 into the power RT. So in the place of nt, just we write down 2n0, and then 2n0 equals to n0 into e to the power RTD. Why TD? TD means here T will be replaced by TD as the time will be double. Time will be you have to consider the time as it will be the doubling time when population will be 2n0. Okay, so now after solving this equation, we'll get that ln e to the power RTD equals to ln2, and finally we will get that TD equals to 0.693 by R, or your ln2 by R. So this will be the expression for TD. This is also very important for the calculation or for the numerical problem purpose. You have to keep in mind. Okay, there is another fact which you have to keep in mind, that generally this TD, or the doubling time of population, that is expressed in the form of percentage. Okay, so if it is for expressed in the form of percentage, then what happen, you have to multiply with the 100. Okay, and then you will get the approximately 69.3, or it is approximately 70. So approximately 70%, or 70 by divided by R, and you have to keep in mind what is the R is that there will be another R also in the next topic. There you should not be confused with that R, because here capital R, that is this is the exponential growth rate constant. You have to keep in mind. Okay, so this is called the your doubling time of population. Okay, so in the same way we can do the half-life time of population also. Okay, so half-life time of population, generally it is expressed by T half. Okay, so generally it is expressed by T half. In the same way that time required when population will be half with respect to the initial population. That means if the initial population will be n0, the final population or nt final, if the initial population is n0, the final population, that means nt, this will be n0 by 2. Okay, so this looks like very simple, but it is not so much simple when you put the value of the nt in the equation of nt equals to e to the power minus r1t. So now here there is an important thing which you have to keep in mind, that why here we are taking the term minus r1. This is very important. Okay, because up to this point, you know that we are taking that r1 is the, or r is the, generally not r1, r is the exponential growth rate constant. Okay, so now why here r1 is taking as the growth rate constant? Actually r1 which you are seeing in this equation, r1 is not here growth rate constant. Okay, why it is not growth rate constant? Look, what is the definition of t half? T half means when population will be half with respect to initial population. That means when population will half means when population that is decreasing, isn't it? Population is decreasing. Population decreasing means there should be decay rate, there should not be growth rate. Okay, there should be decay rate. But if we put the value of, if we put the growth rate constant as r, then the equation will not be right. Clear what I am telling? That if you consider the general equation nt equals to n0 into e to the power rt, like the previous case, r, what is the r? R was the growth rate constant. But here we are considering the decay rate constant, because in the what we are calculating actually when population will be half with respect to initial population. So how it is possible that population will be half with respect to initial population? Obviously their population is decreasing. If population is not decreasing, then it is not possible that population will be half with respect to initial population. So this indicate that we have to use the decay rate constant instead of growth rate constant. So here r1 is the decay rate constant, and you know that decay and growth, that two are in opposite direction, they two are in acting in the opposite direction. So that's why if r is the growth rate constant, we are taking r is equal to minus r1, where minus r1 is the decay rate constant. Okay, so that's why we are using nt equals to n0 into e to the power minus r1t. You have to keep in mind, because this is only important fact when we are calculating the t half. Okay, this was not applicable for the calculation of the td, but this is important for the calculation of the t half. Okay, so you have to keep in mind this fact very carefully. Now if we consider this equation, then it's very much simple. Just you have to put that in place of n0. So look here, in place of n0, here we are nt, we are putting the value of n0 by 2. Okay, in place of nt there n0 by 2, and the rest part remaining same, n0 into e to the power minus r1 into t half. Now here, like the previous case, that t was replaced by t half td, but here we are replacing the t as the t half. Why? Because it will be the half-life time of population. And finally what we are getting t half equals to ln 2 by r1. Now there is an important fact, that what was the value of td previously? td equals to ln 2 by r. But now what is the value of T half? T half equals to ln2 by R1. So only difference, look here, if you consider the two values ln2 by R and here ln2 by R1, what is the difference? The difference is that only constant. In case of doubling time of population, there was the growth rate constant. But in case of half-life time of population, we are considering the decay rate constant. Okay. So if the growth rate constant and the decay rate constant, if they are equal, look here, if the growth rate constant and decay rate constant, at that time the half-life time of population and the doubling time of population both will be equal. Half-life time of population and the doubling time of population will be equal. So you have to keep in mind, if you face the question in that way, that what will be the relation between TD and T half, or what will be the relation between half-life time of population and the doubling time of population, then you have to show these two equations. Okay, these two equations, and then you have to develop the relation between TD equals to T half only when the condition will be R equal to R1. In the same way, like the previous case, here T half equals to, look here, if you take the value, if you want to take the value in percentage, you have to multiply with the 100, and in the same way you will get the 70 by R1, approximately is the percentage if you multiply it with the 100. Okay. So now this is the relation between half-life time of population and the doubling time of population. This is also very important for you, for the question purpose or for the another purpose also. Now come to the point that what will be the graph or curve for the T versus N. N here, N means it is the population. Okay, N means population, T means time. So what will be the nature of the graph or exponential growth curve when we are following the exponential growth rate equation? Okay, this is the exponential growth rate equation. So according to the curve or according to the graph, it is very much clear that the population will be exponentially increased with the time. So if population will be exponentially increased with the time, then only it is possible to get this type of curve. But is it right? That means, is it possible always practically, or the in the general situation, that population will be exponentially increased each and every time? Is it possible? No. The answer will be no. It is not possible that population will be exponentially increased each and every time. Why? Because population growth, this is very much dependent on the external factors. Okay, this is very much dependent on the external factors. Okay, what are the external factors? First external factor is the resource. Okay, so in which place we are considering the population growth, first of all we have to keep in mind what will be the amount of resource present in this area. Then there are so many other types of things are also included. The economical growth of this particular area, we have to keep in mind, either what is the lifestyle of general people of that area. Okay, so that means there are so many external factors which actually control the population growth. But in exponential growth model, look, we ignore actually that fact or that factors. That means external factors are totally ignored when we calculated the exponential growth model. And for this reason, we actually did not consider any kind of effect of the external factors in this graph. and that's why we are getting such kind of graph from the equation, which is showing that each and every time or generally population will be increased exponentially. There is no question of any kind of stagnant situation or any kind of decreasing situation of the population in particular area. So that's why this exponential growth model, it is not appropriate. That means it is not 100% accurate according to the practical scenario. So that's why we have to think about the another model which will be more logical or which will be more appropriate. There we consider that the external factors which exist in our ecosystem or environment, okay, and by that inclusion of the external factors, we will be able to develop a curve for a graph by which we can explain each and every scenario of the environment, each and every situation. Okay, and this model, I already told you, this model is called logistic growth model, or it will be more appropriate, more logical. So logistic growth model we'll discuss in the next class. Okay, this class, what we learned or what we discussed in today's class, first of all we discussed about the what is population growth. Okay, so what is population growth, this we discussed at first. What is the population growth? This was the first of all today's topic. Then we discussed that how we can develop the equation of exponential growth model, the equation of exponential growth model. Okay, exponential growth model. Okay, so that means in exponential growth model there was an equation that nt equals to n0 into e to the power rt, that we developed or that we derived from the exponential growth model. Then we determine that the equation of the td and the equation of the t half, and how td and t half are interrelated with each other. This thing we also discussed, that how they are interdependent. Then we discussed about the curve of the exponential growth model. That means exponential growth model, that this always increasing, and that's why it is not according to the practical scenario. So that's why it is not right. And why not right, we also discussed that why we are not getting the appropriate curve. Okay, now that's all for today. In the next class we'll discuss about the rest part of the population growth, and we'll meet with you in the next class. Thank you for attending my class. Goodbye.